Hi everyone, welcome to unit number 15, Methods of Correlation. So in the last unit we have seen what do you mean by correlation and types of correlation, and these and all we have seen. So in this unit, this is our what we are going to see. The structure of this unit is objectives, introduction, simple correlation, scatter diagram, correlation coefficient, Cole-Pearson's correlation coefficient, Spearman's rank correlation, and sum up of this unit and keywords and terminal questions. What is the object of this unit? In this unit, we are going to explain the concept of correlation, and using the scatter diagram, we are going to visualize the relationship between any two variables, and we are going to compute the simple and rank correlation coefficient between any two variables. So this is our objective. Let us see the introduction. So already we know that statistics is a collection of numerical data relating to one variable only. So in many other situations, the decisions making makers need to consider the relationship between two or more variables. For example, sales manager of a company may observe that the sales are not same for each month. But they know that company's advertisement expenditure varies from year to year. So they are interested in knowing whether the relationship between them, that is the sales and advertisement expenditure. So if they successfully define the relationship, they might use this result to do a better job of planning and to improve the predictions of yearly sales with the help of the regression technique of their company. Similarly, we can say that researchers also, if they are interested in studying the effect of research and development expenditure of annual profit or firm. So the relationship exists between price index and purchase, etc. So likewise, we may have so many examples of that correlation. So here we are going to discuss about that simple linear correlation and simple linear regression. Regression we will see in the next unit. So what do you mean by simple correlation? So if two variables, say x and y, or there is moving in the same or in the opposite direction, they are said to be correlated or associated, I can say. So this correlation refers to the relationship between in two variables. So generally we find the relationship in certain types of variables. For example, you can say so many examples as we have seen. So so if you have any relationship between in the same direction or in the opposite direction, then we can call that as the two variables are correlated to each other. So this is the basic definition we are having under simple correlation. Now we are going to see scatter diagram method. So here, why we are using this method, what it deals with that. So this is the method of studying correlation. Correlation can be studied by these three methods. The first one is scatter diagram method, and another one is second one is Cole-Pearson's correlation method, and the third one is Spearman's rank correlation method. So very first we are going to see the scatter diagram method. So this is the simplest method to find the relationship between the two variables to prepare the dot chart called the scatter diagram. So in this method we plot every point on the of the values in the form of dot on the graph, and we get many as many dots as the number of observations. So from this scatter diagram, we can form an idea whether whether for variables are correlated or not. So we are calling this as a dot diagram or scatter diagram, we can say. So here, if the points, plotted points are very close to each other, it indicates the higher degree of correlation. So here we can say how they are correlated to each other. How they are, that is, if they are whether they are perfect positive or perfect negative, likewise we can have. See this one in the first diagram A. See this diagram number, that is diagram A. In if you even we can see here all the points are plotted. That is, they lie on the straight line. Is it? So straight line running from lower left hand corner to the upper right hand corner. So then there is, we can say that then there is a perfect positive correlation. Okay. Similarly, if the points, that is, if the plotted points lie on the straight line, so it is falling from in the diagram figure, that is in figure B, the straight line we are drawing. So it is falling from upper left hand corner to the lower right hand corner. So in this manner, the straight line is formed. So here we are saying that this is a perfect negative correlation. And the third one you can see, this is high degree of positive correlation. So here the plotted points falls in a narrow band, and if the points rise from lower left corner to the upper left corner, then there will be a high degree of positive correlation. So similarly, we can see the next figure D. Here you can see uh, that is all the points fall from the upper left hand corner to the lower right hand corner. There will be a high degree of negative correlation. So the next one is diagram number. Next diagram, we can see the low degree of positive correlation. So in this one, we can see the points are widely scattered. The points are widely scattered, and the points show. See, it is having the tendency of from a lower left hand corner to upper right hand corner. Uh, so there will be a low degree of positive correlation. And we can see the next diagram. So here the points are falling from upper left hand corner to the lower right hand corner. So here we can say that this will be a low degree of negative correlation. So these are the types of scatter diagram we have. We can see this example under that. Given the following data on the scales and expenses of a firm for 10 months, so month and the sales they have given. So IG, that is January to October they have given with the sales. So um, we can, that is, the question is make a scatter diagram. And the second question, do you think that there is a correlation between sales and expenses of a firm? Is a positive or negative, or what's that variety? That is classifications. That's the question. So that scatter diagram is drawn. See question number 150. There is a month in the month of January, the sale is 50. So according to X and Y coordinate, we have drawn the scatter diagram. Okay, so now we are going to classify it is coming under which type. So here in this figure, we can see the plotted points you see close to each other and reveal on upward trend we have. So there is a high degree of positive correlation between sales and the expense. So next we can see the correlation coefficient. So the correlation coefficient helps in measuring the degree of relationship between two variables, x and y. The methods which are used to measure the degree of relationship will be, we can see. So the first one is Carl Pearson correlation coefficient. So Carl Pearson, he suggested this method of measuring that correlation. Um, so here the Carl Pearson's correlation coefficient or Pearson correlation coefficient between two variables x and y, usually denoted by r of x comma y or rxy, suffix rxy, or simply r is the numerical measure for linear relationship between them. So these are the notations we are using, and the ratio of the covariance between x and y. So R equal to covariance of x comma y divided by sigma x comma sigma x into sigma y, and covariance of x comma y is equal to summation xy by n is the covariance between x and y. R is equal to summation xy by n into sigma x into sigma y. So where x is equal to x minus x bar and y is equal to y minus y bar. And here we have the standard deviation for x, sigma y is the standard deviation for y, and n is the number of observation. So for the above formula, we can computing the Spearman's Pearson's coefficients of correlation. We have the simplest form. So R is equal to summation xy divided by square root of summation x square into summation y square. So this method is used when a small value is solved. We have. So we can see this example. So find the Pearson's correlation coefficient between sales and expenses for the following 10 terms. So the firms we have 10 and sales and expenses we have. So here we are calculating how you see. So we have considered that sales as x and expenses y we have taken, and the column I have considered as x, y, and the next column we have calculated x minus x bar and y minus y bar, and we have calculated x square, y square, and xy. So x bar we have calculated already. We know that x is equal to summation x by n and y bar is equal to summation y by n. So x bar I have calculated, and then x minus x bar we can have, and y minus y bar, and squaring of that is small x, that is small x is equal to x minus x bar. So that column we are squaring, x square column, and y minus y bar the whole square, that we are considering as y minus y bar can be considered as y. So that is y square we have taken and xy. So the corresponding summation values are calculated here. So x is that is the formula, the required, what is the formula for calculating the Pearson's coefficients. R is equal to summation xy by summation x square into summation y square. So, R is equal to, we are applying the value from the table. So 70 by square root of 360 into 22. So the answer is 0.72. So this is the R value we have. So um, here you can see the second example, the data on price and quantity purchased relating to the commodity for 5 months in the given below. So month uh, and commodity we have. Find Pearson's coefficient of correlation between price and quantity and comment on its sign and magnitude. So here the calculations we have done. So as usual, we can consider the price as x and price of the commodity as x and the quantity of the commodity we can consider it as y. So x, y and x square and y square. So if the values are, this is another type, we can use this formula also. So R is equal to n into summation xy minus summation x into summation y square root of divided by square root of n into summation x square minus summation x the whole square into square root of n into summation y square minus summation y the whole square. So just we have applied x square, we have found that x square, y square and xy column. So applying on this formula, so summation xy column, summation xy we have 226 into summation x we have 55. So and then summation y we have as 20. So likewise r is equal to, we are applying on that. So here we are getting the value of R as minus 0.98. So the negative sign of R is indicating the negative correlation and its largest magnitude. The large magnitude indicates that very high degree of correlation. So there is a high degree of negative correlation between price and quantity demanded. So next one we can see Spearman's rank correlation. So the Colpearson's correlation coefficient already just now we have seen. We cannot apply this in all the cases where the direct quantitative measurement of a phenomenon in the study is not possible. Sometimes we require to examine the extent of association between two ordinally scaled variables, such as two order rank ordering. So, for example, we can study the intelligence, efficiency, performance. Likewise, we have so many cases. So, in these cases, we have a certain of degree of association between the ranks of two variables x and y, which is called as rank correlation. So Spearman's rank correlation is a non-parametric test we have, which is used to measure the degree of association between two variables. So it was developed by Spearman, so it is called as a Spearman's rank correlation. So Spearman's rank correlation test does not assume any assumption about the distribution of data and is the appropriate correlation analysis when the variables are measured on the scale that it is at least ordinal. So the formula we have is rho equal to 1 minus 6 into summation d square by n into n square minus 1. So this is the formula for finding Colpearson's rank correlation coefficient. So the notation row we are using, and here the D is nothing but the notation, the term D. What is that? D is a difference between the pair of ranks. So here when the ranks are not given, then what we do? So we can do the ranking from the highest to lowest one or lowest to highest one. We can do the ranking, and then we can do the difference between the pair of ranks. Okay, by using the formula, these things. So let us see this example number one. Calculate Spearman's rank correlation coefficient um, without any ties. Here ties are not there, using the formula. See here 10 students statistics and science marks are given. We are going to do the rank correlation between them. So science statistics, what they have given, we have taken. So the very first one, for statistics, we are forming the ranking. So from the least, that is highest to lowest one, we can form. So or lowest to highest, or both we can apply. So here in this model, we have taken from the highest to lowest one, we are doing the ranking. So the in the statistics, 29 is the maximum highest one, so we are giving the ranking 1 to the 29. And the next number is 23, so we are giving the rank as 2. And next one is 20, so we are giving the rank number 3 for that number. And then 20, so likewise we are doing the ranking. Similarly, degree, that is science. For the science also, we are doing the ranking. So here D, modulus of D only we are finding, and then D square we are finding. D is nothing but the difference between the ranking we have. So D is summation of D square we are calculating. Then we are applying on the formula. Rho is equal to 1 minus x into summation D square by n into n square minus 1. So we have rho equal to, the answer is 0.71. So this indicates a strong positive relationship between the rank of individuals obtained in statistics and science exam. So we can see this next example. The Spearman's rank correlation coefficient, we are going to calculate x 2134. So we are having, so um, so the ranking for that x, we are doing the ranking, and for y we are doing the ranking, and d equal to rx minus ry, and then d square we are finding. So therefore rho equal to 1 minus 6 into summation d square by n into n square minus 1. So summation d square answer is 66. N is nothing but number of observation here. So 7. So 7 into 7 square minus 1. So the calculation if you do means the answer you may have is minus 0.1785. We can see this next question.